do it with fractions, essentially dividing them. Now I'm going to rewrite all these slightly differently. I'm not going to write it as this. I'm going to rewrite these as square root of 4 divided by square root of 3. There's going to be a reason for that in a moment. But for now, this is how I'm going to rewrite them all, okay? Now, we can't, for some reason, ever since the dawn of time, as far as I'm aware, people just don't like to see square roots in denominators. Don't know why. So we do what's called rationalizing it, making it something that makes sense, okay? Making it something that's not an irrational number on the bottom. So how we do that is we just get rid of it by multiplying by the same thing that's in the denominator. So I'll multiply both the top and the bottom by the square root of 3. You do that because you're not changing the value of the fraction. It's essentially multiplying it by 1, but we do that so that way we can thus rationalize it. 3 times 3 on the bottom is 9. 4 times 3 on the top is 12. So square root of 12 over square root of 9. We can simplify a lot of this down. For example, the bottom, the denominator, square root of 9 is just 3. Okay? And the top, you can simplify down because we've learned that the square root of 12 you can break down. I can break this down to the square root of 4, square root of 3, because 4 times 3 is 12. Again, I chose those two numbers because 4 is the biggest perfect square that goes into 12. Thus, we can take the square root of 4, which is 2. You can't take the square root of 3, so you leave that alone. Then there's a 3 in the denominator. Now, let me tell you a trick here. You notice how when I multiplied this on the bottom, it became square root of 9. What is the square root of 9? 3. A lot of times, people just multiply these together, and they keep a little mental note in their head. And this is something that they're going to discuss when you're doing radical equations, when you solve them. Square roots, when multiplied together, when you multiply something by the same square root, like square root of 3 times square root of 3, they cancel each other out, just turning into, ultimately, a regular 3. There's a trick that I'm going to let you know about. So, for example, as I do this one right here, as I do square root of 5 over square root of 32, when I multiply both the numerator and the denominator by square root of 32, instead of having to multiply 32 on the denominator by 32 and then figuring out what the square root of that is, guess what I can do? I can go and skip all these steps and just say the denominator will just be 32 after I simplify it down, because again, square roots cancel each other out. Then all I've got to do is worry about what 5 times 32 is, which is 160, I believe. So this turns into 160, and then I simplify that down as I would. Square root of 160, well, I do know that 16 times 10 is indeed 160. So this turns into, I'm going to just rewrite this, I'm not going to rewrite the bottom just yet, 4 square root of 10 all over 32. Now, I want to tell you something about this. This actually can be simplified down further. Look at those numbers right here. This 4 and this 32. 432. Well, there's a 4 that goes into both of them, or people that are good with fractions can know that 4/32 actually simplifies down to 1/8. So this breaks down into 1/8, and then you can put the square root of 10 right beside of it. But however, if you don't really like that 1 in front, guess what? We don't need it. We can get rid of it. So it's just square root of 10 over 8. Do not simplify down 10/8 though, because again, the 10 is its own type of term, okay? Just like when you're combining like terms, you keep things separate that aren't like terms. 10 and 8 are not like terms. They're not both radicals, and they're not both regular numbers, okay? Last one, probably the easiest one, but the one people get the most confused about, square root of 4 over 25, square root of 25. So, watch this. Guess what? What is the square root of 4? Well, the square root of 4, let me write this down, is 2. What's the square root of 5? Sorry, 25, gave it away. 5. Easy as that. If you want to multiply by a square root of 25 on the top and bottom and prove that this is indeed correct, go for it. But guess what? They're both perfect squares. You can take the square root of both of them. That's what happens when you have fractions. You may have to multiply by whatever the square root is on the bottom and then work your way out, but the math is essentially the same except for that beginning part, which is called rationalizing the denominator.